Hi everyone, thanks for coming. This week we have Mainak. He's one of the organizers of the YNHub, and he's going to explain us give a talk about Git 101 for scientists. I'm going to pass this around so you can sign it if you need
Thanks a lot, Aina. So, as Aina said, I'm also an organizer for YNHub, and I'm a postdoc with Matti Hamalainen in the MEG lab. And today I'm going to talk about Git and version control. Just a reminder, if you want to practice Git, I hope there is some time at the end. Please have your laptop with Git installed. You can just Google search Git and you can find Git and just install it. And I can come around the room and try to help you out if there are any issues. The slides are online. Here's the link. There's also the QR code. You can just scan it to the QR code. It's on every slide, so you don't need to worry about like rushing to get it. All right, so just an outline of what's coming up. First, I'll spend quite some time on delving into the why, because I feel a lot of people don't understand why they need to use Git and version control. And once I have sort of convinced you that you do need Git and version control, we'll get into the how and how to make commits, how to make branches, how to work collaboratively with Git, and some other advanced tips and tricks. So commits, branches, these terms may seem Greek to you right now, but hopefully it'll become more clear as we go through the talk. All right, so just to convince you, I think I wanted to start with my own story with Git, and I was also very much a beginner with Git, and I tend to think that it's kind of a superpower. I wanted to contribute to MNE. It's a popular software package more than 5 years ago, and I didn't know any Python. I didn't know any version control. However, once I learned version control and Git, I was able to, first of all, contribute to many other software packages. I participated in the Google Summer of Code, and I participated in, and I contributed to many other software packages. But also, when you code socially, when you code with other people, you get feedback on your code, and you learn much faster. And this is something I have tried to tell many other people, that you learn programming faster when you learn it with other people. So if you're just starting on the journey, I think learning Git is a very good investment of your time. All right, so I want to clear out two terminologies here, which often get mixed up. One is Git. Git is actually a tool to manage versions on your computer. It's a software that you have installed on your computer. And GitHub, which is an online platform for facilitating patches and code review. So a lot of software, such as the Linux kernel, many important software are hosted on GitHub, and it's where people make patches and reviews, and changes are made. All right, so what is GitHub? I tend to think of it as a social network for geeks. It's like Facebook is for normal people, and GitHub is for geeks. So here's an interaction on GitHub that I took some screenshots of. And you can see that coding can actually be fun. Here, someone has submitted a patch. What you can see in green are lines of code that have been added. It does not matter what's written there in the code, but the comments are kind of interesting. It sort of gives you some idea into what the open source culture is like. So first of all the discussion happens publicly. So nothing is private, nothing is secret. Secondly, it's a little bit informal, not very informal, but slightly informal. You might come across abbreviations like IIRC, LGTM, and when I started out, it was I had to learn what these abbreviations meant. And you use first name. So here, for instance, Yona made a comment saying, when did Alex allow a soft dependency on pandas? And Alex is a professor, and he just used his first name as a PhD student, and that's fine. There's a thank you economy. So here, Eric is thanking Chris Holgrove, and he's like, he's really happy about it. So you thank people and you don't really pay people. So they're all doing work for free. So yeah. And it's self-directed, not top-down. Nobody tells you what to do. You come with your own problems and you say, okay, I have this issue that I want to solve, and can I fix this in your software? And you say, yeah, go ahead, give it a try. All right. So now you're like, okay, I don't do software engineering. I just want to do science. Do I need version control? All right. So here's a couple of usage patterns that some of you might be familiar with. This is usage pattern 1. Here's some code. What you're seeing here in gray is code that has been commented out. And quite often when we want to try some things, we comment out some parts of the code. And afterwards, you just don't know what combinations of line to uncomment to make your code work. Here's another usage pattern, something I was kind of guilty of, is that when you have an editor, you're writing code, and your editor automatically makes checkpoints. And you can go between these checkpoints by using Control or Command Z, and Control Y to go forward. And when you do Control S, you can't go beyond that. So if you do Control Z. So what's the problem with this? Firstly, your history stops at Control S. And if you do a certain sequence of Control Z, Control Y, you just don't know what you're going to get. So it gets very confusing very soon. Here's another usage pattern. You wrote some code and then you feel like, okay, I should have another version of it. You don't want to delete the old code, so you just like append _version 1 to your code. And so I would say use version control for the sake of reproducible science, if not anything else. Here's how I did version control a long time ago. Is I had like folders for different dates, and I would put like different versions of my code in these different folders, and these different folders were sort of the dates that I had written the code. And of course, as you can see, the problem here is that it's really hard to find the scripts that you're looking for. All right, so I hope I've convinced you, at least to some extent, that you should be using version control if you're not already. So let's dive into the details of how to make a commit. So that's like the first basic step in version control using Git. All right, so remember how I talked about these checkpoints with the editor? Your editor makes these checkpoints, and you can go back and forth between them using Control Z and Control Y. Well, Git formalizes the management of these checkpoints. So each of these checkpoints, you call it a commit. And you can go back and forth between them as well. But like, you get a lot of control over what you put in a commit. A commit is a meaningful unit where you can put certain changes that you have made. And you can look at what are the commits you have made so far. Every commit comes with a commit message. So with git log, you can see the list of commits here. And every commit has a commit hash. So it's a unique identifier for your commit. You can see who's the author, the date, and a meaningful message which identifies what your commit is. And you can just make a commit by saying git commit -m and then the commit message. So yeah, so that's how you would make a commit. It's also easy to track what changed in a file. Let's say you made a commit and then you change some things. You can do git diff, and it will show you what files have changed. What you can see in green are whatever has been added. What you see in red is what has been deleted. And you can see in what files what has changed. And you know, it's a bit like what you do with Word documents. If you have ever done track changes, you know, you can see what has been deleted and what has been added, right? So you can use Git even to write papers. I mean, it doesn't necessarily have to be for code. You can do version control on any kind of file. But Git is a bit more than that. It's not just your Microsoft Word. It can manage a repository, not just a single file. You can have a bunch of files, and Git can manage all of them. And the way it does this is that Git knows what files are being tracked, what are not being tracked, and you get a very high degree of control over each file. So with git status, you get an idea of what is happening to each file. So here, if you do git status, there's this long message that you're getting, but essentially there are 3 parts to it. First, you have the untracked files, the files that Git is not tracking. So Git does not care about these files. It will not version control them. So in a folder, you can choose which files to track. Then within the tracked files, you also have the files which you staged, and then the files which you do not stage. So let's say you have made some changes. You do not necessarily need to add all your changes to a particular commit. So you can stage certain changes, and these staged changes are the ones that you would commit. So you can take a file from untracked files or an unstaged file into the staging area by doing git add and then the file name. Okay, so this way Git can know if you have moved a file from one place to another, because it's not just one file, but it's managing like this whole repository. All right, so here's a summary of the workflow to make a new commit. So you edit your file, you do whatever you want to do in the editor. Then you say git diff, and it'll tell you, okay, this is what has changed. And you add the files, the changes that you want to be added to your commit. And then you check with git status if that is indeed the file that you want to commit, and if it is in the staging area. And then you say git commit -m, the name of your commit message. And finally, once you have made the commit, you can do git log, and you can check if your commit has been added to the list of commits. Okay, so that's a bit of a complicated workflow, but it just allows you a very fine degree of control over what you're doing. All right, so next I'll go into branches. It's probably the single most important feature of Git. It allows you to try multiple features at a time. So I think from the perspective of version control, you have to know branches to do anything useful with it. So branching is what allows you to try multiple features at once. So typically what you have is a master branch. So the master branch is your main working copy. And on this master branch, what I'm showing here, these are the checkpoints, the commits. And now let's say you want to try something new. Instead of making a new file, as you did before, you would make a new branch. And so you would say git branch, cool branch, and this would make a new branch for you. And once you made the new branch, you can add your commits. You can switch to that branch by using git checkout cool branch. And then you can say git commit -m and do the commits to your new branch. All right, just one more. And so branching allows you to try multiple features at once. So so you have done this branch, and then okay, so then you can look at what branch you are in by doing git branch -v, and you can see that okay, I'm on cool branch right now. All right, so you have done your commit, you have tried things. Now the time is to incorporate it into your main branch. So you need to reconcile these different branches. How would you do it? So one simple way of doing this is by doing what's called merging. So you have this master branch. Over here with the vertical line, I'm showing the point at which the branch was made, the commit at which the branch was made. So all the commits before that are the same. Then you made your two commits, which I showed in red on your cool feature branch. And in green on the master branch, I have made the commits, like the master branch is also advanced because people are adding new things to the master branch. And now you want to merge these two. So how would you do this? You would say, you would go to the master branch, you would say git checkout master, and you would say git merge cool feature. So merge my cool feature branch into my master branch. So what happens then? I have the commits until the point that the branching was happened. Then you take in chronological order the commits. So first I have this commit from the cool feature branch because it happened before the commit in master branch. Then to that I add the commit from the master branch. Then you add the commit from the cool feature branch, and you add the commits chronologically. Of course, it's possible, it's totally possible that the two branches don't agree with each other, that there is the same part of the code that has been touched by both branches. What happens then? Then you have a conflict, and to resolve the conflict, you need to add a merge commit. A merge commit will take care of the conflict. So it will ask the user, can you fix this conflict? And then once you have fixed this conflict, a merge commit will be made. And then you add your commits as usual. And now once you've done the merge, you have a branch which is sort of a mix of the original two commits. Okay. All right. So I talked about conflicts. How do you resolve conflicts? So when you do a merge, sometimes you'll have a conflict which looks a bit like this. So this is how your text file would look like. Here you see that there are two parts to it. There is this part with these arrows, then there is this line, and then there is this equal to sign thing. And yeah, so there are two parts to this, and you need to somehow reconcile these two parts of the code, which are coming from the two commits which are in conflict. Your goal is to get rid of all these weird arrows and equal to signs. And once you have gotten rid of them, you can commit them, and you can finish your merge. So that's how you would sort of reconcile two branches which may have some conflicts. All right. So another trick to sort of do is editing your history, and there is something called the rebase command to do this. Sometimes what you want is to have your feature branch always up to date with the master. So currently the master has progressed and there have been commits to master. And what you want to do is you want to put your two commits of the cool feature branch at the end of the commits of master. So for that, you would do a rebase. So you would go to your cool feature branch, and then you would say git rebase master. And what that would do is it would take the master branch, and at the tip of the master branch, at the last commit of the master branch, it would add the two commits of the cool feature branch. Okay, so now the question is how the conflicts are resolved. When you did a merge, there was a merge commit. The way the conflicts are resolved is that at each commit, it checks if there is a conflict, and then it modifies the commit of the cool feature branch. So it's not the same commit as before. And now you have two new commits, which resemble the old commit of the cool feature branch, but they're not exactly the same. Okay, so this way you can sort of have your feature branch always up to date with the main development master branch. Okay, so here's a small question. So I have done git checkout cool feature. So I'm on the cool feature branch. I've done the rebase, and so my cool feature branch is on the tip of master. Now, what happens if I go to master and I say git merge cool feature? Will there be a merge commit or not? How many people for a merge commit? How many for no merge commit? Okay, all right. So yes, there will be no merge commit. It will just be added at the end of, because the conflicts were already resolved during the rebase. So that's why you don't have any merge commit. And this is what's called a fast forward merge, because you just take the commits and you add it to the end. All right. So what is the advantage of doing this? Why would I ever want to do a rebase? Any guesses? So the first advantage is the following, that in a software project, quite often you have the person who's working on the master branch is the maintainer of this code repository. The person who's working on the cool feature branch is someone like you and me, who is not the owner of the repository. So these are two different people. And there are probably hundreds of pull requests happening on this software project. And this person who's doing the merging, he cannot resolve all the conflicts for all the people who are making these contributions. So by doing the rebase, you are shifting the burden of resolving the conflict from the person who is maintaining the master branch to the person who is maintaining the cool feature branch. Okay, that's the first advantage. The second advantage is that when you do a rebase, your commits are ordered by features, not chronologically. And this is sometimes preferable because if you want to look at your history, then it's much neater to see that they're ordered by features and not by time. What is the disadvantage of doing this? What is the disadvantage of doing a rebase? What is the potential issue? If you have a feature branch which has 50 commits, okay, so, and then you do a rebase, you might potentially have to resolve 50 conflicts. And this is a pain for the contributor. When you do a merge, you just make up one merge commit and that's it. During a rebase, every single commit of your feature branch might need resolution in the worst case. So that can be a disadvantage. And the second disadvantage is that rebasing changes your history. It changes your history, so you should never do it on your master branch. That's evil, because if you do a rebase on your master branch, people who have branched before you did the rebase will not, their branches will be invalid. You won't be able to merge the branches into the master branch. So typically what we recommend is you always do a fast forward merge on the master branch and a rebase on the feature branch. Okay. All right, so summary of branching. So you make a branch from the master branch. You take the latest master branch, you do a branch on that. You go to your feature branch, cool feature, make commits. See slide 11, how to make commits. Then you rebase with master. This is optional. If you're working for a big project, you may want to do it. If you're just working with a friend, you probably don't need to do a rebase. And then you do, when you're ready to merge, you check out the master branch and you merge the feature branch. All right. And in the process, you may have to resolve any conflicts if necessary. All right. So far, all we have talked about is something that you could just do on your own or with a friend. But quite often, you use Git to contribute to big software projects. And for that, you need to know how to work collaboratively. So first, some high-level concepts. So you have a repository in the cloud. And this could be GitHub. It could be GitLab. It could be Bitbucket. It could be an SSH server that you maintain. So they all have their own advantages and disadvantages. And then you have a repository owner. In this case, it's my boss, Mati. And he has a copy of the repository on his own computer. And so there's the repository on GitHub, which we call, on this repository, we call it upstream. And Mati has access to push and fetch from this repository. So he can take a branch on his own computer and he can push it to the upstream repository, and he can take a branch on upstream and he can fetch it. But enter the postdoc of Mati, and he wants to contribute to this very popular software project. But unfortunately, he cannot push directly to upstream. He only has right to fetch branches from this repository. So what can he do? Luckily, GitHub provides you an interface to deal with this. You fork the upstream repository, and you make another repository called origin, which is normally called origin. And this fork is what he has push as well as fetch access to. So what he would do is he would get the fetch. He would fetch the latest master branch from upstream on his own computer. He would make a branch on his computer. He would work on this branch. And then you would push it to origin. And once you push the feature branch to origin, from the GitHub interface, you can make a pull request. All right. Okay, so just keep in mind there are 4 different repositories, each with their own branches. So it's not like SVN where you have like one repository. There are like, this is a distributed version control system. You have 4 different repositories. All right. So once you have these 4 different repositories, they're in the cloud. So somehow you need to tell your program that where these repositories are. And this is done with the concept of remotes. Remotes are like aliases. You just say git remote add upstream, and you give it the URL of your repository. So upstream is on MNE tools, and then origin would be on the fork. And so you tell Git that these are my remotes. And then when you look at your remotes, you can check where your remotes point to using git remote -v. And you can also remove remotes, you can add remotes, you can rename them. You can do a whole bunch of things with these things. But it's important to know that a remote is what helps you know that, okay, this is where my repository lives, the other repositories. So this is basically the recipe for collaborative Git. So you get the latest master branch, you delete your current version, you get the latest master branch from upstream. You make a branch from this latest master branch called cool feature. And then you go to this cool feature branch, and you make your commits, and then you push it to origin. And once you push it to your fork, you make a pull request on GitHub. Okay? All right, another quiz. So in which repository is the feature branch merged? So I made this pull request. So now I've not yet done the merging, right? So I've made the feature branch, and someone has to merge it into the main master branch. So where is this going to happen? Is this A, upstream, B, origin, the owner's local computer, or the contributor's local computer? How many for A, upstream? 1, 2, 3, okay, 4, 3.5. How many for origin? Oh, a lot of people for origin, okay. Owner's local computer? 1 person, 2, 3, okay. And contributor's local computer? 1 person, okay. All right, so most people voted for B. Well, you have 2 options. Option 1 is to do it on the GitHub interface on upstream. So when you make a pull request on GitHub, you have an option. So you can say, okay, they've made this pull request, and let's merge this branch onto the upstream master branch. So that's one option. The second option is the following. This is for more advanced users. You have upstream, you have origin, and Mati is the owner. What he could do is the following. He could get the cool feature branch from the origin of the contributor, and he can get the latest master branch on his own computer. Then he can do the merge locally on his own computer, and then he can push the latest master branch to upstream because he has access to push it. The contributor cannot do it because he cannot, even if he merges it locally on his own computer, he does not have rights to push it back to upstream. Okay. And similarly, merging that is happening on origin will be to pull requests that have been made to the repository that is the fork of this repository. All right, some advanced tips and tricks. Sometimes what happens is that you made a, there was a problem in your code and you found a bug and you want to search for this bug. And you just want to find that commit which created this issue. And for that, you can use git bisect. So you say you have this history of commits, and these commits could be thousands of commits. So it would be crazy to just go through each commit trying to figure out what is the commit that caused the problem. So you say, okay, this is my bad commit. So, and then you try two commits over here shown with green and with red. And you say, okay, this is my good commit, you tell Git, and this is my bad commit. And then Git proposes you one commit. And you try that commit, you see if it works. And you say, oh, no, this doesn't work. So you say, this is a bad commit. Now Git knows that once this is a bad commit, okay, so the commit must lie between this. And then it proposes another commit, which is roughly halfway between these two commits. And that way you sort of narrow down on the bad commit. So it's essentially doing a binary search, which takes log n base 2 for n commits in the worst case. And so MNE, for example, has 14,000 commits, and that is just 14 tries. Instead of trying 14,000 times, you're trying just 14 times. So this is a really efficient way of figuring out what caused an issue in your code at some point in history. Another thing that you might be interested in is who broke my code? I've been working so hard on this project and someone else broke my code. Who did it? So for that, you have git blame. So you can say git blame, you can tell the line numbers, and you can also do this from the online interface. You can just click blame, and it will tell you for each line who touched that code. And you can also look at the git log for specific lines. So you can see what are the commits that touched a specific line of code in the past. All right. So that's it. I don't know how we are doing on time. I think we have a lot of time. Yeah, so yes, so if you want to practice, you can stay. If not, yeah, you're free to go. So you can download Git from here, and you can install it. And there's this repository for practicing Git that I created. You can go here. So I'll just keep it here for a while so that you can find it. Yeah, tell me.
Can you explain more about staging and unstaging? Why? Reversed the staging and somehow it was lost. I still don't understand the point of having staging and unstaging. Maybe I don't understand what it is.
Right. So staging allows you to not commit everything that you have changed. So
so if it's unstaged, then you won't commit.
Yes.
So only the staged file will be.
Yes. Yes. So there are also more advanced tricks that allow you to sort of even like add. So let's say you have changed 3 lines. You can use git add -p to add 2 of the 3 lines in your staging area. So sometimes, like you've tried a few things and you know that, okay, this part of it is clean, but I just don't want to commit the rest. So you just add that to the staging area and then